Hello students, welcome to ST.SEBASTIAN Pre-University College. So this video is a continuation of scalars and vectors. So in the last video we studied about the magnitude of two vectors. In today's class let us study about the direction of the resultant of two vectors. So in the last video we studied about vector addition by analytical method. So we studied this derivation, the magnitude of resultant of two vectors r is equal to the square root of p square plus q square plus 2pq cos theta. Now let us study about the direction of resultant of two vectors. For this derivation we are following the same diagram what we are used for a previous derivation, what we used in the previous derivation. Now you know about what is the vector p and vector q. These are the two vectors. Now we have to take the triangle CAM. Students, you have to observe the diagram. The triangle CAM, with respect to angle theta, the sin theta we can write, it is opposite side divided by hypotenuse. So opposite side CM divided by AC. Therefore CM is equal to AC sin theta. The same triangle, let us find what is cos theta. Cos theta is equal to adjacent side by hypotenuse, that is AM divided by AC. That implies AM is equal to AC cos theta. Now let us take the triangle OCM. The triangle OCM, for that triangle let us take tan alpha is equal to CM divided by OM. That is opposite side divided by adjacent side. Adjacent side is OM and CM is the opposite side. So tan alpha is equal to opposite side by adjacent side. Tan alpha is equal to CM divided by OM, which is equal to OA plus AM. Now tan alpha is equal to, now in previous we solve the expression CM is equal to AC sin theta and AM is equal to AC cos theta. That we have to substitute in the tan alpha equation. Therefore tan alpha is equal to AC sin theta divided by OA plus AC cos theta. Now what is AC? AC is equal to vector Q. OA is a vector P and AC is equal to vector Q. So that is a length, isn't it? So we can write tan alpha is equal to Q sin theta divided by P plus Q cos theta. This is the direction of resultant of two vectors. Now let us see the special cases. Now case 1, vectors are parallel. Now if the two vectors P and Q, they are parallel to each other, then the resultant vector is also having in the same direction. If they are parallel, the angle theta is equal to 0 degree. Now what is the magnitude value we will get and what is the direction value we are going to get, that we will see by using these formulas what we derived in the previous slides. The magnitude is equal to the square root of p square plus 2pq cos theta. Here theta, this is for a parallel, theta is equal to 0 degree. So you have to put the value cos 0 degree plus q square. Cos 0 value is 1. Therefore r is equal to square root of p square plus 2pq, where cos 0 value is 1, plus q square. This is in the order of a plus b whole square. Therefore r is equal to square root of p plus q whole square. So the square get cancelled. So r is equal to p plus q. Now what will be the direction if the two vectors are parallel to each other? The tan alpha is equal to q sin theta divided by p plus q cos theta. Now theta is equal to 0 degree. So sin 0 is 0 and cos 0 is 1. Therefore, you will get the value tan alpha is equal to 0 degree. This is the first case. Second case, if the vectors are perpendicular in the sense the angle is 90 degree. See, you can observe the vector P plus vector Q. Their alignment you can observe. Their alignments are perpendicular. Therefore, the resultant vector we can see in the third side. So P and Q, it makes a perpendicular. Two vectors are perpendicular. Therefore, you will get the magnitude. Magnitude R is equal to square root of P square plus 2PQ cos 90 plus Q square. Cos 90 value is 0. Therefore, R is equal to square root of P square plus Q square. Now what about the direction? Direction tan alpha is equal to Q sin 90 degree divided by P plus Q cos 90 degree. Sin 90 value is 1, cos 90 value is 0. Therefore, you will get the value Q by P. So alpha is equal to get the value of alpha, we have to do tan inverse Q by P. In the third case, if the vectors are anti-parallel means they are exactly opposite to the parallel. So the theta is equal to 180 degree. Their directions are opposite. Now, see the vector P and vector Q, their directions are opposites. Therefore, the resultant vector is in the another direction. The magnitude of vector, you have to use the formula again. R is equal to the square root of P square plus 2PQ cos 180 degree plus Q square. Now the value of cos 180 degree is minus 1. Therefore, you will get the expression R is equal to square root of P square minus 2PQ plus Q square. Here the value of cos 180 degree is minus 1. So therefore, you are getting the negative sign there. So this is in the form of a minus b whole square. So R is equal to square root of P minus Q whole square. Therefore, the square get cancelled. R is equal to P minus Q. Now let us see the direction. Tan alpha is equal to Q sin 180 degree divided by P plus Q cos 180 degree. So here that value it comes 0 because sin 180 is it's 0. Therefore, the denominator is also comes doesn't matter if the value is you are having minus. Okay. Therefore, the entire term it becomes 0. If P is greater than Q, alpha is equal to 0 degree. If P is less than Q, you will get alpha is equal to 180 degree. So these are the special cases for a magnitude and direction of resultant of two vectors. Let us see the unit vector. A unit vector is a vector that has a magnitude of exactly 1 and drawn in the direction of given vector. A unit vector is a vector of unit magnitude. Unit magnitude in the sense its magnitude value is 1. A unit vector is a vector whose magnitude is unity. A unit vector has no dimension and unit. So unit vector is having no dimension and unit. It is used to specify a direction only. See, here it is, you can observe that the vector A, that is a unit vector, but it is a representation is A cap. A cap. The unit vectors along x, y, z axis of a rectangular coordinate systems are denoted by I cap, j cap and k cap respectively, since these are unit vectors. So unit vector is represented by A cap. A unit vector is a vector that has a magnitude of exactly 1. It does not have any dimension and unit. Its only purpose is to specify a direction in a space. A given vector can be expressed as a product of its magnitude and a unit vector. For example, the vector A is equal to A into A cap. For example, vector A may be represented as magnitude of vector A into its unit vector along its direction. So vector A is equal to magnitude into unit vector, that is A into A cap. A into A cap, we can write it as a vector A. So vector A means it is having magnitude as well as direction, right? So here blue A, it indicates the magnitude, and red A, it indicates the direction. So A into A cap is a vector A. This is a Cartesian unit vectors, the representation of unit vector in the coordinate system. You can observe in the XYZ plane the unit vectors are I cap, J cap and K cap respectively. They are perpendicular to each other. Now let us see the resolution of vector. It is the process of splitting a vector into two or more vectors in such a way that their combined effect is same as that of the given vector. So what is the resolution of vector? It is the process of splitting a vector into its components. The process of splitting a vector into its component is called resolution of vector. So any vector A, can be expressed as a sum of two vectors. Those two vectors are called components. Components of a vector are the set of vectors whose resultant is the original vector. So you can observe here the vector A. Vector A, that is represented by, it will be splitting into two components. So that is the resolution of vector. Now you can observe here, under the rectangular component of two-dimensional vectors, the vector A along the x and y axis, this is a two-dimensional plane. So vector A, its component along the x-axis is vector Ax. Vector A, the components along the y-axis is vector Ay. Now vector A, we have to observe the second diagram. The vector A along the Ax, along the x-axis the unit vector is I cap. Along the y-axis the unit vector is J cap. Ay J cap, Ay J cap which is equal to vector Ay, Ax I cap which is equal to vector Ax. So we have to add to get the vector A. It is a sum of the two components, that is components along the x and y axis, Ax I cap plus Ay J cap. So this is the how we are going to splitting a vector into its components, is called resolution of vector. A vector can be resolved into any number of components. A vector can be resolved into any number of components. The resultant vector is a vector which is the sum of all its components. Resultant vector, so here the resultant vector is the vector A, which is a vector, it's a sum of all its components, that is the components in the x and y axis. Now the rectangular components of two-dimensional vector. Now you have to observe that same diagram. Now you have to, with respect to theta, we can write the sin theta is equal to opposite side by hypotenuse ay by a. Ay is equal to a sin theta. You have to rewrite. Cos theta is adjacent side by hypotenuse. Therefore, ax is equal to a cos theta. The magnitude and direction from components. We already derived the magnitude and direction of two vectors, isn't it? Now the formula for this vector A, its magnitude and direction, we can write vector A x I cap plus ay j cap. Its magnitude is A is equal to the square root of ax square plus ay square. Because they are perpendicular, theta is equal to 90 degrees, so you got the value A is equal to square root of ax square plus ay square. Direction you will get theta is equal to tan inverse of ay by ax. So here tan theta is equal to opposite side, that is ay divided by adjacent side ax. Therefore theta is equal to tan inverse of ay by ax. Now the rectangular components of three-dimensional vector. If we represent the vector under the three-dimensional, then the components will be 3, isn't it? Two-dimensional you will get the 2 components. For a three-dimensional you will get the 3 components, because we are represented in the coordinate system, 3 coordinate system. Now vector A is equal to, it is the vector A dash plus vector ay. Therefore vector A is equal to, it's a component of x, z and y. Vector x plus vector z plus vector y. Vector A is equal to, so here vector ax plus vector ay plus vector az. Now vector ax can be written as its magnitude into direction, that is ax I cap. Similarly, vector ay can be written as ay j cap. Vector az can be written as az k cap. So this is a representation of a rectangular component of three-dimensional vector. So here ax is called x component of vector, ay is called y component of vector A, and az is called z component of vector A. So the rectangular component of three-dimensional, under the two-dimensional we already studied. Now in the three-dimensional you can observe the cos alpha is equal to, it is ax divided by a. So it is adjacent side by hypotenuse, that is ax by a. Therefore ax is equal to a cos alpha. So for the rectangular component, so for the three-dimensional we are using cos alpha, cos beta and cos gamma. Cos beta is equal to ay by a. Therefore ay is equal to a cos beta. Now rectangular component in the three-dimensional, cos gamma. So these are the rectangular components of three-dimensional. We are represented by cos alpha, cos beta and cos gamma. Cos gamma for a z-axis, az divided by a. Az is equal to a cos gamma. Now, so the magnitude and direction from its component under the three-dimensional vectors. Now vector A under the x, y, z plane, the vector A, it's a sum of its components along the x, y and z axis. That is vector A is equal to ax I cap plus ay j cap plus az k cap. Its magnitude we can write A is equal to the square root of ax square plus ay square plus az square. Its direction we already got the expression, that is cos alpha, cos beta and cos gamma. Now we have to do alpha is equal to the cos inverse of ax by a. Beta is equal to cos inverse of a by a. Gamma is equal to cos inverse of az by a. Let us have adding vectors by its components. Now we can add the vectors by its components. We cannot add the vectors. So we can add the vectors by its components. Okay. Let us take the two vectors, vector A and vector B. Vector A is having the components ax I cap plus ay j cap plus az k cap. Vector B is having the component bx I cap by j cap plus bz k cap. Then we are going to add the two vectors. So the resultant vector is equal to vector r is equal to the sum of two vectors, vector A plus vector B. Now you have to put the value of vector A and vector B. Therefore vector r is equal to ax I cap plus ay j cap plus az k cap plus bx I cap plus by j cap plus bz k cap. Now we will write the x components together. Vector r is equal to ax plus bx. So we can write I cap is common, that is in the outside the bracket. Similarly we can write the j cap terms together plus ay plus by that into j cap plus az plus bz that into k cap. Now this we can write vector r is equal to ax plus bx, that we can write it as rx, that is a resultant x components, that is rx I cap as it is we will write plus ry j cap plus rz k cap. So vector r is equal to rx I cap plus ry j cap plus rz k cap. Here rx is equal to ax plus bx, ry is equal to ay plus by, rz is equal to az plus bz. This is how we can add the vectors by its components. Now this is what we observed in the previous slide, that is how we are going to add the vectors. Now let us study about how we can multiply the vectors. So multiplying vectors. Multiplying a vector by a scalar. Multiplying a vector by a scalar. Okay. If we multiply a vector by a scalar, so scalar s, we get a new vector. If you are going to multiply the vector by a scalar, you will get the resultant vector is a vector. Its magnitude is the product of the magnitude of vector A and the absolute value of s. S is a scalar. Its direction is the direction of vector A if s is a positive, but the opposite direction if s is a negative. So it takes the values of s. But if you are multiplying a vector by a scalar, the resultant value is a vector, and its magnitude is the product of the magnitude of vector A, and the absolute value is value of scalar. Its direction is the direction of vector A if s is positive, but opposite direction if s is a negative. It depends on the value of scalar. See it here. If s is a positive, then vector A, here the 2 is a scalar. We are multiplying a vector by a scalar, then the resultant value is a vector. If s is a positive, you are having the resultant vector is also having the same direction. So here the 2 is a positive, so the 2 vector A, it comes in the same direction as the moving in the same direction of vector A. If s is a negative, then See the value of 3 minus 3 here. So it's a vector A, it becomes minus 3 vector A. So its direction, resultant vector direction is opposite to the direction of vector A. Now multiplying a vector by a vector. If we are multiplying vector by a vector, then there are two ways to multiply a vector by a vector. The first way produces a scalar quantity. So the first way, it produces a scalar quantity and called as a scalar product, which is also called as dot product. So multiplying a vector by a vector, there is a two ways of multiplying a vector by a vector. One is a dot product, second one is a cross product. So the first way produces a scalar quantity and called as a scalar product, which is also called a dot product. The second way produces a vector quantity and called as a vector product, or it is called as a cross product. These are the two ways of multiplying vector by a vector. If you are multiplying vector by a vector, then there is a two way. One is a dot product, another one is a cross product. Under the dot product, you will get the scalar product. Under the cross product, you will get the vector product. Now let us see the scalar product. It is a dot product. Vector A dot vector B. We have to read like that, okay? That dot. Vector A dot vector B is equal to, it is AB cos theta. Vector A dot vector B, that is equal to AB cos theta. AB cos theta. So here the dot products of two vector A and vector B is denoted by vector A dot vector B. The dot product of two vectors is defined as the product of magnitude of two vectors and cosine of the angle between them. So we have to represent it in the cosine angle, that is in terms of cos theta.